projects. In this video, we are going to explain about the project title, Enhance the Security for Cryptocurrency Transactions Harnessing Machine Learning. Introduction. Cryptocurrencies have become increasingly popular for their ability to facilitate secure and efficient transactions without the need for intermediaries. However, the security issues inherent in these transactions pose significant challenges that need to be addressed. While blockchain technology, which underlies cryptocurrencies, ensures transparency and prevents tampering, it also introduces risks such as hacking, fraud, and unauthorized access. The project aims to use advanced machine learning techniques to make cryptocurrency transactions more secure. By quickly identifying and stopping malicious activities as they occur, it seeks to enhance the reliability and trustworthiness of these transactions. To achieve this goal, the project plans to set up a system for monitoring cryptocurrency networks in real time. It will also develop a flexible security framework that can adapt to changing threats. Through thorough testing and validation, the project aims to ensure that these measures effectively enhance transaction security and protect against potential attacks. Objective of the project is creating advanced machine learning algorithms specifically tailored to identify irregular patterns and potential fraudulent behaviors occurring within cryptocurrency transactions. These models will be trained to analyze transaction data in real time and promptly flag any suspicious activities for further investigation. Establishing a sophisticated real time monitoring system capable of continuously monitoring the integrity of cryptocurrency networks. This system will actively track transaction flows, network nodes, and other relevant metrics to promptly identify any deviations from normal behavior, helping to detect and mitigate potential security threats promptly. Developing a scalable and resilient framework designed to enhance the overall security posture of cryptocurrency transactions. This framework will encompass various security measures, including encryption protocols, access controls, and authentication mechanisms, ensuring robust protection against unauthorized access, fraud, and other cyber threats. Conducting comprehensive testing and validation procedures to evaluate the efficacy and reliability of the proposed security approach. This involves simulating various attack scenarios, analyzing system responses, and verifying the effectiveness of implemented security measures in mitigating known security threats effectively. Providing actionable insights and recommendations derived from the project's findings to stakeholders within the cryptocurrency ecosystem. These insights will help inform stakeholders about emerging security risks, best practices for improving transaction security, and strategies for mitigating potential vulnerabilities, ultimately enhancing the overall security posture of the cryptocurrency ecosystem. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing libraries. This module involves importing necessary Python libraries that will be used throughout the project. Common libraries include NumPy for numerical computations, Pandas for data manipulation and analysis, Matplotlib or Seaborn for data visualization, scikit-learn for machine learning algorithms, TensorFlow or PyTorch for building and training neural networks, Flask for building web applications, and SQLite 3 for database management system. Importing dataset. In this module, we load the dataset into Python environment. This can be done using Pandas for common file formats like CSV, Excel, or databases. Once loaded, we can perform various operations like data cleaning, handling missing values, and data transformation. Exploratory data analysis, EDA. EDA involves analyzing and summarizing the main characteristics of the dataset. This includes statistical summaries, distribution plots, correlation analysis, and identifying patterns or anomalies in the data. EDA helps in understanding the data set better and informing subsequent data processing steps. Data visualization. Data visualization is the graphical representation of data. It helps in understanding patterns, trends, and outliers in the data. Common visualization techniques include histograms, scatter plots, box plots, and heat maps. Matplotlib and Seaborn are popular libraries used for data visualization in Python. Data processing. This module involves preparing the data for modeling. It includes steps like feature scaling, encoding categorical variables, handling missing values, and splitting the data into training and testing sets. The processed data is then fed into the machine learning model for training. Training and building the model. In this module, we select an appropriate machine learning or deep learning algorithm based on the problem at hand. Then, we train the model using the training data. This involves fitting the model parameters to the training data and optimizing them to minimize the prediction error. After training, the model is ready to make predictions on new data. Performance comparison. Once the models are trained, their performance is evaluated using appropriate metrics such as accuracy, precision, recall, and FN score. This helps in selecting the best model for deployment based on its performance on the test data. Flask framework with SQLite for sign up and sign in. Flask is a microweb framework for Python used to develop web applications. In this module, Flask is used to create a web application that allows users to sign up and sign in. SQLite is a lightweight relational database management system used to store user credentials securely. User gives input. When a user interacts with a web application, their input data is processed to ensure it's in the correct format for prediction. This involves data validation, normalization, or encoding. Once the input is pre processed, the trained machine learning model is used to make predictions on the input data. The given input is pre processed for prediction. When a user interacts with a web application, their input data is processed to ensure it's in the correct format for prediction. This involves data validation, normalization, or encoding. Once the input is pre processed, the trained machine learning model is used to make predictions on the input data. Trained model is used for prediction. Final outcome is displayed through front end. Finally, the predicted outcome is displayed to the user through the front end of the web application. This could be in the form of classification result, regression output, or any other relevant information based on the application's purpose. The front end is responsible for presenting the information in a user friendly manner. Algorithms used to implement this project, we have designed the following algorithms. The first algorithm is linear regression. Linear regression is a statistical technique used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. In the context of enhancing security for cryptocurrency transactions, linear regression is utilized to predict transaction volumes, identify outliers in transaction amounts, or assess the risk associated with specific transaction patterns, providing valuable insights for fraud detection and risk management. Coming to the next algorithm, which is Navy Bayes. Navy Bayes is a probabilistic classifier based on Bayes' theorem with the assumption of feature independence. In the realm of enhancing security for cryptocurrency transactions, Navy Bayes model is used to classify transaction as fraudulent or legitimate based on features such as transaction metadata, transaction amounts, sender or receiver addresses, and transaction history. By leveraging probabilities, Navy Bayes can effectively detect fraudulent activities and assess the risk associated with transactions, aiding in the prevention of fraudulent transactions and enhancing transaction security. XGBoost. XGBoost, extreme gradient boosting, is a powerful machine learning algorithm known for its efficiency and effectiveness in handling structured data. In the context of enhancing security for cryptocurrency transactions, XGBoost is employed for various purposes such as anomaly detection, transaction classification, and ensemble learning. By leveraging its ability to capture complex relationships and patterns in data, XGBoost can effectively detect suspicious activities, classify transactions based on their likelihood of being fraudulent, and improve overall prediction accuracy through ensemble techniques, contributing to enhanced security and fraud prevention in cryptocurrency transactions. Comparison graph. Comparison graph offers a visual breakdown of how our models perform across essential evaluation metrics. Models are compared with the evaluation metrics accuracy, precision, recall, FN score, sensitivity, and specificity. This is the comparison graph. Here on the x-axis, we have the algorithm name, and on the y-axis, we have the evaluation metric score. Here, the blue color represents accuracy, orange color represents recall, green color represents precision, red color represents FN score, purple color represents sensitivity, and brown color represents specificity. Coming to accuracy, accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positive and true negative, to the total number of instances. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions. True positives plus false positive. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances. True positives plus false negatives. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. The algorithm, which is performing best in all the performance metric, will be used for prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. If we are a new user, we need to register first. So click on sign up button here. I have already registered myself. So click on sign in button here. Here we need to enter the username and the password which we have registered and then click on login. We have logged in successfully. So here we need to enter these parameters to predict whether anomaly is detected or not. Before entering the parameters, let us discuss the parameters. The first parameter is in degree. In degree refers to the number of incoming transactions to a particular address or entity within the cryptocurrency network. It can be an indicator of how active or involved a particular entity is within the network. Out degree. Out degree refers to the number of outgoing transactions from a particular address or entity within the cryptocurrency network. It can provide insight into the spending behavior of activity of a particular entity. Bitcoin in. This parameter represents the total amount of Bitcoin received by the system or entity under consideration. It is measured in terms of Bitcoin units. Bitcoin out. Bitcoin out, conversely, Bitcoin out represents the total amount of Bitcoin sent out from the system or entity. Total Bitcoin indicates the net balance of Bitcoin for the system or entity, calculated as the total Bitcoin received minus the total Bitcoin sent out. Mean in Bitcoin. This refers to the average amount of Bitcoin received per transaction. It provides insight into the typical size of incoming transactions. Mean out Bitcoin. This parameter represents the average amount of Bitcoin sent out per transaction, offering insights into the typical size of outgoing transactions. Now let us enter the parameters value. I'm entering the values. So here I have entered the parameters value. Now click on submit button. So here we can see the result, that is anomaly transaction detected. Let us enter another set of values. Click on try again. So here I'm entering another set of values now. So here I have entered another set of parameters. Now click on submit button. So here we can see the result, that it is a safe transaction. Let us enter another set of parameters. Click on try again. So here I'm entering the parameters. So here I have entered another set of parameters. Now click on submit button. So here we can see the result, that anomaly transaction is detected. Let us enter another set of parameters. Click on try again. I'm entering the parameters. So here I have entered the parameters. Now click on submit button. So here we can see the result, that it is a safe transaction. In this way, just by entering the cryptocurrency transactions, we can predict whether it is a safe transaction or not. Now click on sign out button here. The conclusion of the project is successful implementation of machine learning techniques has significantly enhanced the security of cryptocurrency transactions by detecting and preventing fraudulent activities in real time. Integration of real-time monitoring system and scalable security framework has enhanced the integrity and trustworthiness of cryptocurrency networks, providing stakeholders with improved protection against security threats. Performance comparison of different machine learning models has yielded valuable insights into selecting the most suitable algorithms for detecting fraudulent activities in cryptocurrency transactions, contributing to the optimization of security protocols. Integration of the Flash framework with SQLite for user authentication functionalities has enhanced the usability and security of the system, enabling users to securely sign up and sign into the platform, thereby ensuring the confidentiality and integrity of the cryptocurrency transactions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.